Hello students, now I am going to explain the unit of rate constant unit of rate constant. So student, first of all what we are going to do, there is a table is there, but initially if you see the table, you won't be able to understand until or unless you know the derivation. So dear student, how to do the unit of rate constant? So there student, rate is equal to, what is student, rate is equal to, no, if you talk about the first order, if you talk about the for first order reaction, for first order reaction. So what is the for first order reaction student? Rate is equal to molar concentration. Rate depends on the molar concentration of only one reactant. Okay, so a power 1, right student? So rate will depends on the molar concentration of only one product, one reactant. Now what we can do is student, rate, if you are, that is removing the proportionality constant, to rate is equal to a power 1, right student? So student, so that is k is equal to rate constant of what student? That is first order reaction, rate constant of first order reaction, rate constant of first order reaction. Now, rate is what student? Rate also you know, change in concentration per unit time. Okay, change in concentration per unit time. What student? That is per unit time. So how can you be able to solve it, student? If you see rate, how can you write here student? Rate. So rate you can the change in concentration. How is student? Per unit time. So that is, it will come mole. Okay, per liter, mole per liter, and that is, t, time is their time, so that is second, equal to k. And again this is the molar concentration, so molar concentration is what student? Mole per liter, right student? So this mole per liter and mole per liter will be cancelled out because both are in the numerator. So what is 1 by second? 1 by second is equal to, what is coming student? K. 1 by second is equal to k. So k is equal to, what will come student? Second inverse. So that is, unit of okay, first order rate constant, unit of first order rate constant is how much student? That is second inverse. This is our first one. Now for we are going for the second order. Okay, so rate constant of unit of, that is unit of rate constant of, that is second order reaction, second order reaction, unit of rate constant of second order reaction. Okay, so how can you do student? If you talk about the second order reaction student, second order reaction, so second order reaction is what student? In the second order reaction, that is the order of reaction is what? Sum of the power of concentration. So for second order the power will be how much student? Power will be 2. Okay, or you can say rate of reaction depend on the two molecules. So A plus A, or A and A, that is A square, you can say, like that you can understand student. So that is, so rate is equal to, what we can write student? Rate is equal to A square for second order reaction. So rate is equal to, how much will come student? K and A square, rate is equal to K A square. So rate, what is student? That is dx by dt. Okay, dx by dt is equal to K A power 2. So this is the molar concentration of any reactant. So how much is molar concentration? That is mole per liter, student, mole per liter. And here is second in, per second, that is mole per liter, that is molar concentration. The square bracket is molar concentration, molar concentration is molarity, mole per liter, equal to K, and this is power is there student. So mole per liter, and this will be square student. So how can you see student? Mole per liter upon second is equal to K into, what will be there student? Mole per liter multiply by mole per liter. So this this mole per liter and this mole per liter is will be cancelled out. So how much will be there student? 1 upon second is equal to K into mole. Okay, and liter inverse, right student? So what would be the unit student if you cross multiply it? So what will be coming student? K is equal to, that is it will come student second, K will come student, K equal to, this is either you can say student K equal to, this all will be coming in the same way student. K is equal to 1 into 1 is there student, okay, and this all, that is also multiply will be there student. K is equal to, this all is multiply, K second into mole into liter inverse is equal to 1, right student? So that is K is equal to student 1 upon what is coming student, second into mole into liter inverse, right? So what will be there student? Second will go in the numerator, so that is second inverse. Mole will be go in the numerator, mole inverse, and liter. So K is equal to second inverse, mole inverse, liter. Okay student. So for the second order reaction student, mole inverse, liter, and second one inverse. This is the unit for the unit for second order unit for second order rate constant, unit for second order rate constant, right? Next one, if you talk about the next one student, what you will be able to do the next one for the zero order is reaction student, for unit for okay, rate constant of unit for rate constant for zero order reaction student, zero order reaction. So how you will be able to calculate the unit for the zero order reaction student? That is quite easy only student, you will be able to solve for the zero order. So student, for the zero order reaction student, rate of zero order reaction is proportional to what student? No, it does not depend on the concentration of any reactant. So that is A constant, suppose A is the any reactant, its concentration should be 0. Means A means anything value 0 is what is student? That is coming 1. So what we will be able to write student, rate is equal to K into A power what is student? A power 0. So rate is equal to what we can write student? K into 1, because A power 0 means 1. So rate is equal to what student? Mole per liter per second, right student, is equal to K. So K is equal to how much coming student? That is it's coming mole, liter inverse, and second inverse for the zero order reaction. Okay student, mole, liter inverse, second is 1. So this is unit of, unit for rate constant of what student? That is zero order reaction, right student? So you will be able to understand this student. Here in the graph also may mention this all things, that is for zero order reaction, mole, liter inverse, second inverse; for first order reaction, second inverse; and for second order reaction, mole inverse, liter, and second inverse. Thank you so much for watching, for friends.